I guess. Oh.
I was gonna ask real quick, the simulation one.
It really depends on your mesh.
Oh.
Anywhere between maybe like, for the steady one, anywhere between like 2-3 hours maybe.
Okay.
And then for the pulsatile one, maybe like 5, 6, 7, 8 hours, probably around that order.
We've been submitted wrong file on the website.
What was the question that said the DAT file? Cause I
All
asked,
yeah.
asked him, he's like, oh, it's the VTP, I'm like, well, the other one says DAT though, but he submitted it and it's taken, let's look.
Oh, the BCT.
Yeah, they say all either way, so I just saw one. And then-
Yeah, either one will work.
No.
Oh, really?
Yeah,
The
the VTP doesn't work.
It's
Oh,
really
really?
give an arrow.
Oh, okay.
Well, it'll load it, and you can get the zip file and all that stuff, but it won't run on,
Parallel.
Verity.
Oh, okay.
When you change the time rate, parallel, it's all white, the whole world is all
Oh,
white.
okay. I see.
And then you cannot time scale, just rescale it.
I see, okay. Yeah, I usually use the DAT one just because that was kind of the traditional way, but I thought they've recently added the VTP.
I know, we've been, the whole yesterday, we've been submitted, and then it finished after like,
Finished
took
like
like half an hour.
Yeah.
45
And then
minutes.
we go to the website, say, all arrow, cannot
Oh.
open that file, I'm like,
That's why
I see.
I was like, cause I think I remember you saying like, oh, like give it up to like 24 hours to run, so I'm like,
Yeah.
everyone probably submitted theirs, so it's probably gonna take that long.
Yeah, it's busy right now. dude.
Yeah.
Everyone's saying that because when I last taught this, like people would submit and just go through the queue with that.
Yeah,
But like lately, people are saying it's like 2, 3, 4 hours just.
so it'll say like queued and then, cause like mine says executed, so does that mean it's?
Executing just either means it's in a queue or it's run. You have to actually click on the job itself.
Oh, okay.
oh.
So if you want, there's a little button at the bottom when you submit a job that says send me email update.
Oh, yeah.
Okay, then it'll send you an update. It'll
Oh.
send you an email once it's
Yeah,
active.
it only send us like, send me like 30 minutes for my steady state one,
Yeah,
and then finish after 30 minutes.
I see.
Sorry. Well, double check is. Thank you for it.
Yep.
Then we're still waiting on the.
Is there, like, I got results and they look very logical to me.
Yeah, we could take a look today.
But my
Usually-
pulsatile was a lot smaller.
There's,
It ran a little less, it was like 3 hours compared to my 4.
oh, really? Interesting. Okay.
My
Let's-
bullet files are like 400 megabytes, but my steady was like 1.5 gigs.
Oh, we'll take a
I'm
look.
still
today.
converting the pulsatile results, so
Okay.
it's like still running at this week, but.
Yeah, I uploaded a MATLAB script onto Canvas today. So I think the issue with yours, I think because your model is so small, because you have like a little newborn baby, that I think the 100 mils is too large for the flow rate. That's probably what's causing the issue. So I have this MATLAB script where you can scale the input. So we'll talk about that today.
Okay, for
Yeah.
sure, cause I changed the steady one from, there was like two, so it
Yeah.
was like two, it was like 0, like step 0 or something,
Yeah,
-100, and then the next one is also -100.
yeah,
So I just changed both of those to -5,
great,
and
perfect.
then I changed it for both inputs,
Yeah,
and then I kept the time sets the same as when you emailed me the like 0.0005,
yeah,
and then I sent it around like noon.
okay. It's
So,
still probably still waiting in
yeah,
the,
it's still
okay.
submitting.
It's busy right now for some reason. I wonder if it's, yeah, a lot of people are using it right now.
Okay.
Because these jobs that we're running are actually not that, I mean, 72 processors sounds like a lot, but for a cluster like this, it's actually pretty small. So I'm surprised that these small jobs are taking so long, but I guess it's just really busy right now.
I've been using 56.
Okay,
Mine is pretty like works.
okay, good.
So like 50 million.
Yeah.
Yeah, mine's one like 110 with that 20,000,
Uh-huh.
but I just ran it.
Yeah. But yeah, even then it's still pretty small. Like there's people who run like with thousands of processors for a job. Those are people running like, did you guys talk about like simulating turbulent flow and CFD?
Using,
Yeah,
like
we
not
do
using
have-
RANs, but
Yeah.
using a DNS.
DNS is crazy. DNS, you need like
It's
thousands of
watching the
processors.
flow is insane. Like
It's great. It's
super
beautiful.
cool looking, yeah. it's
Yeah.
beautiful, yeah.
I think
That's the best word.
We're doing.
It was like a sphere with the like eddy.
Yeah.
What do we call it?
Vortex shedding.
Yeah, vortex.
Yeah.
Watching them in like rainbow swirls, and then you go RANs, it's just like a triangle.
Yeah. It's cheaper, but it's you kind of get what you pay for.
That's where you go. It's not necessarily that you're solving for any point. It's just you're at such a point that like it's at the smallest more eddy size. Right?
Yeah.
So we're doing, our final project is like simulating turbulent flow over like a car.
That's cool.
Like in RANs.
That's super cool. Yeah.
No, it actually looks like seeing the results like float like in peer review problem.
Yeah, actually,
and it
the
like
results-
makes sense.
I still have the results open.
Okay, let me, I'll address the crest and then I'll come. I'm really happy. Yeah, I mean, I've been hearing just so many good things about the CFD course. I'm really glad you guys are going over
It
turbulence.
was killer at first, like,
Yeah, that's a pretty.
you're learning peer review, how to use a Linux terminal
Yeah,
and do like.
it's hard. CFD is normally just a grad level course. And even then, it's like a second or third tier grad level course too, so. Who's calling me? Oh, it's just my alarm. Okay, it's 4 o'clock. Let's go get started. All right, welcome everybody. Good afternoon. This is our last time together. So our last time to be in this room, or for those of you on Zoom, last time on Zoom. How's everyone doing today? Good. All right, so I know a lot of you have been working on your projects. It's great, and you guys have been contacting me with questions and stuff. Always, I'm happy to answer. I think I'm mostly staying on top of stuff, but definitely don't be afraid to email me. I know I said today is going to be just all office hours, but there are a couple things that I wanted to address just because as a group, just because these are kind of constant things that are coming up for multiple people. So I'm gonna do that first, and then after that we'll do just kind of I know people in class, or you guys brought your laptops, and so I'll come around and look at either the results that you have or just any other issues that you have, and we'll get sorted through that. And then of course on Zoom you guys can we can screen share and stuff too. Okay, so the first thing I wanted to go over today has to do with your inflow boundary conditions. So I know I've been telling everyone up until this point that we're just going to work with an average of 100 milliliters per second. But turns out actually, what we're discovering is that for some of your models, that 100 milliliters per second actually isn't appropriate. Mostly because the models are either really small, or maybe you have a really young patient, or for those of you who have animals, I forgot that some of you have rabbits. 100 milliliters per second is a little bit too big. So I think what those people have been experiencing is that when you try to run the simulation with such a high flow rate at the inlet, you're getting results that essentially diverge. So without getting too much into the details, it'll make a lot more sense if you took CFD. But when you have time-dependent flow, there has to be a very careful balance between the maximum velocity in your simulation and the time step that you choose. And basically, those two have to be kind of set. They have to be related to each other, basically. So what was happening is that for these really tiny models with very small inlets and very small vessels, when you applied a flow rate of 100 milliliters per second, it caused the flow to accelerate so much that the simulation was having a really hard time keeping up with it, essentially. So there are a few ways around this, and so one way that you can do this is that you can simply just reduce the time step size until the simulation converges. But for some of your models, I think that's just not feasible given given how small your models are. So the other option that you have in order to fix this is to lower the velocities, which in our case means lowering the amount of flow that's coming into your models. And actually, this is actually kind of the more appropriate method, because for those of you with kind of infant models, or maybe those of you that are in cerebral vascular, some of you with cerebral vascular, 100 milliliters is just fine. And in fact, I've already seen a couple results that are good. But if you're getting results that are either diverging or they're not giving you making much sense, you have to reduce the flow rate. Okay. So the way that you do that is that you need to adjust the dot flow file that you're inputting into SimVascular. So remember, there's two dot flow files that we're using. There's a steady state one and a pulsatile one. To modify the flow rate in the steady state one is very easy. So you're going to go to this cap aorta.flow that's available on Canvas. You're going to open it up in a text editor. So if you're on Windows, Windows may not recognize the .flow extension, so you may have to force it to open up with Notepad. That's fine. Okay. And what you're going to see here is basically a data table. A data table that measures the flow rate as a function of time. Okay. So the way to read this is that the first column, that is your value of time, and your second column is your value of flow. Okay. So basically, the way to interpret this is that at time is equal to 0, the flow rate at our inlet is set to a 100 milliliters per second. Okay. and at time is equal to 1, the flow rate is still 100 milliliters per second. So this is a steady, a steady simulation where the inlet flow rate never changes. Okay, so to lower the amount of flow, you would basically just lower this 100 to a smaller magnitude number. So what that number is for you, I think some of the PDFs may have some numbers in there, but for a general rule of thumb, you can either I would either reduce it by a factor of 10, so you can make it -10, or if you have multiple inlets. Let's say that you have a congenital heart disease model with 2 inlets, you can set both of these to -5 so that the total amount of flow coming into your model is 10 milliliters per second. Okay. So I would definitely do that and then rerun your simulation, and then you should hopefully see that the simulation will have a much easier time conversion. Okay. So that's for the steady simulation. For the pulsatile simulation, it's a little bit more difficult to modify, because if you open up the pulsatile inflow file, you'll see that it's time dependent data, and so the flow rates kind of change as a function of time. So technically speaking, the way that you can do this is that you can just go through every single number and divide it by a factor. So let's say we want to reduce this by a factor of 10, you would just move the decimal place over for all of these things, right? But that's not really feasible when there's 1,000 data points here. So we're going to do this a little bit of a better way. Let me change this back. Okay. So to make things a little bit easier for you, I've uploaded a MATLAB script onto Canvas. And so to find it, you would go to our Canvas site here, you'd go to the Files tab, you'd go under SimVascular, and you should see that I've uploaded a MATLAB file called scale pulsatile inflow.m. Okay. So you would download that file, you would open it up in MATLAB, and you want to make sure that this MATLAB file is in the same folder as your generic pulsatile inflow.flow. Okay. Okay. And so this is what that script looks like. It's a very simple script. It's very short. Okay. And what this file is going to do is that it's going to basically load in the generic pulsatile inflow and then scale everything according to your desired flow rate right here. Okay. So the only line that you have to change in this code is line number 8, where you input the amount of flow rate that you want, or the average flow rate that you want for your model. Okay. So let's say that we want to modify that pulsatile inflow to have a total flow rate of 10. Okay. 10 milliliters per second. So you would put in a positive 10 right here, and then you would just simply run the script. Okay. And that's what your new waveform looks like. And if you look in the folder, you should see that a new file has been created called scaled pulsatile inflow. Okay. And so this is your new flow rate file with the reduced, for most of you, it's going to be reduced flow rate. Okay. So you can use this script right here to modify your pulsatile inflow and set it to be the exact flow that you want. Okay. So if you've been having a hard time with your simulations, you're running them and the simulation is diverging. Basically what that means is that you run your simulation, you convert your results, and you don't see, there's no pressure, there's no velocity in there, or you get very strange values of pressure and velocity. You can run this script and reduce the inflow amount and see if that helps you with your results. Okay. All right. Any questions on this? Okay. All right. So I think that's the number. Oh, go ahead.
This was just like on Canvas.
It's on Canvas. Yes. So if you go to Files, it's inside the SimVascular folder for files. Yeah. Okay, so with that, I think that's probably the most consistent issue that I've been seeing from people. I mean, there's of course been kind of smaller issues with file conversions and things like that, but hopefully that should help you guys out for those of you with smaller, for the non-aorta models, I should say. So if you have an aorta model, 100 milliliters per second should be good, although there have been a couple cases where they haven't. But for an aorta model, 100 milliliters per second should be fine. If you have a smaller model, or if you have an animal model like a rabbit model, you may need to reduce your inflow. Okay. Okay, so with that, I'm going to make my rounds around the classroom. If you're on Zoom and you want me to take a look at something, just leave something in the chat. I'll probably make my way back here, depending on how many questions in the class, maybe around like 15, 20 minutes. Okay. You have your results?
This is a study.
Okay.
Sure.
but
So you ran with 100, it was okay.
yeah, which I now think about is probably higher than what I don't really see. I expected it to be really high there.
Okay, that's
It's contracts way too fast.
Can I see the pressure? I mean, I see the values of the pressure here. but I
The
wanna see-
pressure is, it's like all pressure up top, which makes sense. Interesting.
Okay,
Because of the heart.
Yeah.
and it- But I mean, I would expect this to be a little more red, I would imagine. but-
yeah. So the pressures are, I mean, the trend is correct, and so, I mean, this is exactly what I expect for,
Yeah,
like you
because
said,
basically the pressure, it hits a bottleneck, so it can't, this
Yeah.
doesn't pressurize the same.
right? So the trends here are all good. The only thing that's worrying to me is that there are negative pressures here. So that might indicate to me that you might have to lower your inflow amount. But the results already, I mean, the colors look fine, and the wall shear stress looks fine too. But yeah,
So it's a general trend, just the values seem off.
yeah, the values seem off. So that means they're probably all off, but they're all off by the same amount.
Yeah, like if I could find the correction factor.
Yeah. But that's good. I mean, that's a good sign. Even with high inflow, it's still looking really good.
Yeah, it's like the stream trace.
Okay. That's really good. It is a little bit worrying that it looks like there's very little amount of flow going out of
Yeah.
it, because even with the core patient, I still expect a decent amount of flow to come through there. So you can try maybe just the steady simulation with the lower inflow.
Should I just kind of Google what the average like?
I would.
It's a 6 month or 7 month old rabbit.
Oh, it's a tiny rabbit too. I would go with. Let's try 5 milliliters per second.
Oh, okay.
So reduce it by factor.
Okay. Okay. And then I think it's.
Oh, yeah, that takes a while. That's good. I mean, it's good science for sure.
Yeah, because that file would be massive.
Yeah.
That steady state was like 1.7.
That might be what happened with the pulsatile one. It might have diverged, and then once it diverges, it just quits.
Oh, okay, so
Yeah.
I don't probably.
You probably need to reduce it.
Yeah, okay, it's still, okay.
Do you have results?
Oh, no, I was just talking about like the CFD file.
Okay.
For the, those like just show off the card.
This is getting a double dose of CFD.
Yeah.
No, it's nice, because it's like we used to have you paired it.
It's really cool.
Where did is that Dr. Martel store?
Yeah, actually,
He got it from some university in Europe.
Oh, okay.
They created the whole, like, there's a set of models. So we're testing between like a sedan, a station wagon, a fastback.
That's
But
cool.
the whole front of the car is identical, and then we're doing like with underbody details,
Yeah,
smooth bottom, stuff like that.
that's awesome. That's really cool.
Those
Nice.
for this, we just, it'll change it automatically. or
It'll change on, so it'll produce a new file. So the file that it produces is called scale pulse. It'll leave this one on.
Actually, it was.
We'll use that one. We'll use this one.
Those are the two inlets.
I never really before, but I want these.
And I would keep the other time steps still.
Oh,
0.005 and
I would keep that one. Yeah.
Which is fine. Yeah, and then, hey, I checked my peer review on. We're going. They can do it start. Which I wrote. Too. Which I think we.
That's what he mentioned though. Essentially, why not? Why isn't he? So MPI is a parallel processing. I think you should.
So I downloaded this one. I want one. I already.
And install it.
It installed and then like. We need to send that.
Were you a little compare view?
No, it's like-
Never.
Like I click on this, it's like the welcome. And like it has it like showing it's like I can change it, prepare to remove it, and I click prepare and do that, and then it's still is the same. So that's why I was, once I repaired it, it should. I don't know why it's like
Try removing
moving
it
it, I'll
now.
re-download it.
Try the other one. I honestly don't know the difference. Go back to the website.
Between this one.
Oh,
Or there's the.
well, So the zip should be a pre-compiled. You can try the zip one. With the zip one, it's like one zip it, and it's all kind of like pre-built. That's kind of the folder. And so inside there is the variables. So that one probably is more stable. It just takes up more space.
MPI over the regular.
No, just do the right.
They have the same
Yeah,
pattern.
the MPI, I don't know why.
Yeah, that's.
Oh, okay, there's an MPI version.
You do have that.
MPI
MPI, MSI, and then.
I'll put it.
MPI is usually what you use to run CFP actually, so anything that's like heavy on computing, honestly, doesn't do anything. It's just.
I downloaded the MPI, one, maybe that was my problem.
But yeah, I would just go with the regular.
Okay.
The thing, this is the result that I got.
Okay.
But I'm not seeing the VTU, we're supposed to get a VTU file, right?
Yeah, you're supposed to convert it, so
Oh.
I'm assuming here, so go to the convert results.
Oh.
Yeah, and then for this one, you see like the 17 plus light out.
If I need like more.
This one.
Yes. Yes, and so you enter your.
Only-
Start. This is your steady state.
Yeah.
Only unless it's 100. And then 10.
Like I used all on the. Like I think I have.
Ask you where to
one
stay.
more and you just say.
Yeah, so so this is gonna produce a folder. It takes.
Oh, okay.
Just give it. I don't know. It's not. Yeah.
Maybe.
I mean, you know what he's saying, like, is it their studies thing? This supposed to they got.
Actually, not sure that.
Yeah, it's hard to move the ball. Yeah, because it's like. Space, but it's a.
I know.
It's a 2D. Usually
Like they been on
This is that's like.
Were they contacting it to like?
Further getting data, man, it sucks.
Yeah, it was like.
Yeah,
oh,
I, the
Yeah.
I think lost in also, then you can do it, but you research.
He's like, no, I didn't.
I have to find it like that.
I think we'll set him up, we get all this stuff, maybe. And then, that's really.
I'm not going to be lost. Yeah.
It's not for Bayland, for sure not.
Yeah.
Yeah, you see, that's why.
Yeah.
Oh, yeah.
Yeah, that's great.
It would be cool, like, if you guys want, I would love it.
Except it is a-
It's called raw, it's in the stream, it's like, it's actually like a half hour. You see where it's on the screen. It'll borrow seat,
That's good. That's interesting.
1 gig.
Yeah, we can just lock your
My way, the honor was how I'm gonna post out. It's 10 minutes.
Okay. Cool. You can download it.
Rock stop. Oh, no, there it is. That's what it's.
Any questions?
No, it's gonna say, yeah, it took a while, so.
Yeah, it does take so long. Okay. Keep it.
Yeah, sure.
Yeah, it's on here. Okay, I'm here, Caleb. Let's take a look.
Alright,
You want to share your screen? Hang on, let me.
yeah,
Okay, good. I can hear you too.
cool. Let's see, can you see my screen?
Yep.
Okay, so, I mean, I've tried it a bunch of different ways just because I keep getting stuck,
Yeah.
but, so I mean, right here's the tar file, right?
Yep.
And then you.
What?
But
what's
inside
the
this is
thing
only
you zip it? Are you using
7-zip,
Oh, even with 7-zip, it's not.
because you just, I mean, click on it, right click, extract files, right?
Try open archive. The first one.
Just brings up.
Okay, and go extract. Oh, what the heck?
Yeah,
Okay, hit OK. This it, yeah. Okay, close that for a second. Actually, you mind if I drive for a little bit?
yeah, how do I? Oh, cool.
Okay.
Yeah, I mean, I've pretty much re-downloaded and like tried it a bunch of different times. So that's why I think that it's like
Yeah.
something with
For some reason,
how the file's downloading maybe on my end.
Maybe. I mean, I was able to download, so I downloaded your results straight from the cluster itself. I don't know why it's not letting me click this.
Huh?
Your desktop background is too beautiful. I think it's lagging. It's like it's lagging everything.
Yeah, my
Okay, there we go.
internet's
Oh.
freaking out.
Actually, let me
Oh.
let me give up the remote control. I think it's a little bit laggy when I'm trying to control. Try double clicking that one and see. You could try WinZip. WinZip is the one that I typically use. But it should work with 7-zip too. Oops. Oh shoot. Oh, pretty awesome.
Huh. Yeah, I guess that was weird.
Oh yeah, I guess it just disconnected you.
My connection just freaked out on my end.
Yeah, what happens when you double click that tar file that was inside the extracted folder, I guess.
It brings up how do you want to open this file?
Try opening it with 7-zip again.
And then just gives all opening with what?
Try opening that tar file with 7-zip again. The one that was extracted but wasn't actually extracted, I guess.
Okay. Mm,
I wonder if there's like some set because I know when I use 7-zip on my computer. Let's see.
That doesn't really pull anything out. Whereas-
Quick question.
Yeah.
For the pulsatile, did you also want us to like reassigning those resistances, like by multiplying by 10?
Yes.
Okay.
Yeah.
So that applies to both steady and pulse.
Whatever resistances you use for
okay.
the pulse element.
Yeah.
Okay, go inside that 772 procs case folder.
So I guess it worked for that one, just extracting it from there. See if it works from this one. Oh, it was
The 72 procs case folder is the one that you should have. But let's see what's inside it. Oh, internet problems. Results finished converting. They look
It would be 10 to 15. It's 5 and 5, so it's just one.
You said for my money, I should just do 500 units, have my one inlet?
Yeah.
No.
Yeah.
Okay. And then you just multiply all my resistances by 10 then?
By 20 for you, because you're making a reduction from 100 to 5. But since Daniel has 2 inlets,
Oh,
5
that's why
times 2 is.
And my total resistance was like 1200, so now it's way higher.
Yeah. That's fine. That's mostly just aimed to keep the pressure consistent.
I did one, the new one.
Okay.
Final photo. I did, I did 12 hours in the day. 0.2.
That should be fine. Yeah. Yeah, not all.
Oh, hard. I wasn't about 3 years since,
Yes.
so we'll just read that. I wrote this up, that's how.
Which open phone?
Yeah, so this one holds now, so this one.
And it just prints it actually breaks up in a chain.
You're gonna see the results from the chain. So confirms that it only, it might still be converted. And there should be 8. Yeah, so I think it's probably still.
So actually, I talked about I will be learning combine and then for each spot, let's sum it 1200 times.
Oh, it's working in that case. You just have to. Yeah, so it's gonna say that it's not responding. It's just working so hard that it can't respond.
So that's why I turned it off.
Yeah.
So I assume that you need the converter for it right now.
You could. Actually, let me see these.
Oh, shit, 24K.
Yeah, it looks like it didn't complete. So, because it only process up to step times 7,500. Like 12,000, 4,000. But it's good. I mean, it's you're on a good track. Actually, can I check something like? Where is your
That the
My simulation began moment of truth.
basically what I'm checking for here is in CFD, there's a quantity called the residual, which is basically like a measure of the percentage. So that's this number. So I'm looking to see that if this, see if this gets below, usually want to be somewhere around 10 bucks. Okay. Yeah.
so I need to convert again.
Yeah. Just convert and then just let it, it's gonna take a while.
Turn off my computer.
Oh, yeah.
Also, yeah.
Maybe do it like and then go to you. But it looks like the simulation results came out this. Yeah. So this is diastolic pressure. That's the main pressure. That's the systolic pressure. The bigger one.
Okay, we're taking it out.
Yeah.
That's all I'm saying.
Yeah, so for your case,
Other than
yeah, so for your case, I changed in this case, but there's no kind of look up. One is a very common. It probably might not pop up there, but yeah, that's probably, it's like basically like with your best.
Oh.
So we talked about it briefly in that's a lot of stuff about get abdominal.
You know, more than how much you
You think I'm good.
Exactly. So that's the one that I'm.
Yeah.
And then,
You go, we can buy.
yeah, so it's like, so if there's a lot of.
I know, but I want to.
How
Is
is
that
that
one
on
of
the
the for us?
a lot of things here.
It's probably in the
You probably won't see it, but I think this page is.
Yeah, that's all.
But you can say that, usually for these types of patients, So this is like, but it's not present. in the patients. Oh. And I let you them like. Yes. Oh, sorry. Just. Oh, wow, got a question. Yeah, they. I submitted it by. Yeah, we submitted. Oh, yeah, they did change some of the policies where it's easier for people to get. What's called allocation now, which is great. So I mean, if you're a new researcher, it's easy to get started, but then I think just way more people are using it right now.
Simulation.
Yeah.
It's pages in 3 minutes.
It's good you guys are starting now, but yeah, people that start next Friday. I'm a little nervous. Yeah, so you said you have office. Yeah, so the normal time or is it normal last time? Normal time and then, but it'll be all virtual. Okay. Yeah.
And yeah, I actually made this. I saw, this is the only thing I saw.
Okay.
Yeah, so I'm assuming that's the thing.
Yeah, so you have a rabbit. Yeah.
Yeah, because I looked all of the.
So one thing for you, so just because no one else is doing it about it, your info might be a little bit too high. Were you here at the beginning of the class? Oh, no, so I think you're probably gonna have to reduce your. Because with that high on info, your simulation might get or on unstable, just as your model is small. Okay, so for rapid models, I was suggesting that instead of 100, you use 5. And so you would have to actually change the. Okay. So do you have the full cost? Actually, I can show you.
Yeah.
I can show you the steady one, and then for the pulsatile one, I have some spreadsheets.
What did you get for the?
So we're gonna have to order that.
What did you get for the project? Then you make it sometime.
Okay, so instead of, so right now, the way to research that is we're setting a equal amount of 100 mil. So instead of 100.
I'm gonna run
Yeah. That's what Jack. I think probably, I think with 100, I think the simulation. Okay, so if you just do the same first, and then for the pulsatile one, there's the scripts I have online.
Oh, yeah.
Let me go around, make one round, go ahead and practice simulation with this, and I'll run say. Oh, yeah, and then, yeah. Oh, sorry. What's up?
So I downloaded the zip, but
Yeah.
I just don't know like. What to do with it.
Would have been.
It's running, but I actually.
Maybe that's actually.
Are you doing?
But my hand, see.
There it is.
With the heart to do?
No, it's very.
No, I think it's when.
So I was like, I kind of like looked at it, and I was like, I don't know if it's gonna be. good.
Should work. All the, I mean, these would be literally all the libraries. It's right here. I don't know why they just kind of mess. There you go.
Okay, cool.
And, okay, yeah, there you go. Yeah.
Sir, there's something I have to redo. So it's the same result. So it's still wash.
A wall shirt. Okay. Because I saw the loss.
Yeah, I don't know why that legend is still there.
It's because of the stream, it's because of the stream. The stream tracer has this on top. This looks good, actually. So, so the pressures, I mean, this is what I expect. You have a correlation. So basically, whenever you have a correlation, it's always gonna be a big pressure drop. That's the worst thing we force that's good. And the pressures are all positive. That's a little interesting. Although I think my just might not have to be with low. Usually when you have like jets, that's coming in. That's
Yeah, this, right?
It might be getting that. Let's make this also work. It's 5 months. Let's get it. Yeah, there you go. Okay, that makes sense. So what's happening is the flow's coming in, it's hitting the wall right here. And so that's what's causing it. There's basically a stagnation. And then that also causes a jump in the wall shear stress too. Yeah, so, yeah, it's actually, it looks strange to me at first, but I think it's all right because, and that's usually what you see in correlation too. It focuses a jet, which shouldn't be there. And it creates water. Yeah,
Oh, it looks good on them, you know, so the pulsatile one, I don't have to change the flow then?
no, so you just
Okay, so they
But it's also.
yes.
In my, right now, my understanding is I downloaded the SP silver and I created the data right now.
Yes.
I have to change.
Yes, so the flow file, you don't want. Well, you can put it. This flow file determines the amount of fluid that's coming. So right now it's at 100. So basically what that means is that every, or flow rate that's coming in is 100 milliliters, which is typical for a human. But for a rabbit's a lot smaller. So I think, so what I'm saying for a rabbit, let's reduce this to 5. Let's say this. So we're basically reducing the amount of flow coming in the back of the point, which makes sense with the rabbit. 120 inside. Oh, he said. So what you would do then? Re-upload that. This one right here. You uploaded this small file. Use the.
When you get. When you get. Then this sounds, the software say
The
no.
other thing that you have to do, just you
Yeah.
want to make sure.
And then keep going.
So you have to change these.
I started mine like 15 minutes before class. And
So the way, I'm guessing the way that you.
Then because the step before that, the step, right?
Resistance.
Yeah, I was just.
Although I
Okay.
tried to do
So
100
then,
milliliters
for the
of
resistance.
blood flow through a funny rabbit.
Oh, yeah.
A funny rabbit that's too big.
I know, man. You have a little.
Because we're reducing the amount of flow by factor of 20, you have to. Establish these willing influences by instead of guessing for your total.
Remember the BCT, the BCT dot net or the BCT dot BTD? Yeah, dot, it's only work with the dot net, not.
Okay.
Yeah, or, right?
Yeah.
And then because on my file, the dot, that one is.
Yeah.
Is that way they should work?
Then I would. I put it in your pulsatile simulation. You know, for your pulsatile one.
It should take a couple hours.
Well, no, exactly, but then for the pulsatile.
No, I know, but like once it starts, it should take. I mean, it's one here, man. I'll find out.
So actually, I don't have the script, so actually, I'll tell you.
Oh, you should be pretty cool. Bro, I'm not
The
2.2
resistance
million.
is the same. It's the same kind of.
Oh, I lowered it. I had 2.2 million.
You know, you can.
And beside that,
Yeah.
I wanted like that.
I straight calculus.
But if you're reducing the flow, you just want to make sure you.
One you can plug 72.
Alright. Well, you take your thing and you divide it by 20,000.
Yeah.
So you take your.
It would.
It's you need more floors. It'll be faster. This goes.
Yeah, I just got.
Okay. Really, like, you know, I was like, oh, I think it was like. Okay, let me see.
In your view, if you have something to like, if. I just like, if you can tell us something, everybody just.
I wait.
Like, how is that like set?
It's, there is a way if it diverges really badly, then the solver knows by itself. But there are some cases where it's like diverging, but not quite
It's
there.
like awesome.
Yeah, but those are really hard
That's
to catch.
what we're running is we've never been able to like computer, the car ones to actually converge to
Yeah.
a tolerance level, but. We've shown that like. 8,000 iterations, it's just doing this consistent zigzag. Like,
Yeah.
The first, I don't think 1,000 iterations, you see it drop and then it just.
Yeah.
Forever.
Those are hard to catch because it's like not quite at the level where it's like, if it explodes, like.
Yeah, you can
Then,
see.
you know, But then if it's like, if it improves a little bit, because there are some cases, especially with really short flow, where convergence is extremely slow. It takes a really long time, so you don't want to kill those kind of simulations. But sometimes like you can see it, that's like, you know, at a certain point, it's just not doing anything. So those ones you would want to kill. Do you have the page for the indicator?
Oh, last one is.
And to 100.
With this, oh, no, for-
Yeah.
And maybe like that's what happens.
I don't
Whenever,
Well, I don't know why
I change
it's fine, sit down.
this time stuff. Yeah. To.
Cool.
When I click off of it. And you will pay the whole time.
Oh,
Yeah, so I'm not, I don't know, maybe I sent it in with the wrong set.
let's see. So, can I see the file that you sent me?
It should
Should be something.
I just tried to do mission two right now.
Right, so, I mean, I guess I'll be good.
These are your two.
Yeah. I only did Sublime, so I should not.
Oh, okay. Oh, so fine.
I already have some.
Oh.
So it should-
Looks like it reset this. So if it's not showing up here, the way that you can modify you can modify the solver behind. You just open up in a text editor and just do.
Right here.
And then send it to even with much smaller. And it didn't even improve at all too. That's the.
It like ran for like a little bit longer, like a minute long.
Change the same.
You have a Airbnb installed? I usually. This BCT or BTP, you can actually open up here to actually see.
Send it.
So like it just shows the apps.
You can actually, there's a filter, in Airview here called one by vector. You can actually see the velocity profile display. So these are the velocity. It looks really good, just because of the scale. Looking at the max velocity, because the thing that actually convergence is actually the velocity. They're correlated, of course. So if you have less flow, you have less.
That's when you read. You see what the better, small back, so you can see the part of you. You know what I'm saying?
Right, that's probably one more. So I think let's keep the flow rates the same because there's 5 milliliters per second per gallon. It's already pretty slow. But let's modify this. Let's make it really small. So instead of 1 millisecond, let's put let's try this instead. many elements are in your mesh?
Well, like 2 million.
So we will submit this to the. I would love to get you an answer before you leave today. So I was gonna say maybe you can run it on your computer, but you probably don't play it your computer. I just want to make sure that it's making it past the making it past the first 5 time steps.
Look at my hand.
Oh, okay. Okay, why don't you try running it for now? Yeah, just close everything.
There is one thing I have from this.
That's fine, that's fine. But yeah, just go ahead and finish it, and just create it and run it, and then if we can get to like step 5 or 10. Then I think it's gonna be pretty good, then we will, we'll probably kill it and then submit it to the cluster.
Yeah, so you have to create data files, some issues.
You should be like it just run, try hitting just run.
Oh, no.
Okay, how are you? Okay, definitely close Mac. Yeah. So go to the file folder where the simulation is. Or go to your semester file. Your schedule. Okay. So eventually. Well, I think what it's doing right now, what it's doing right now is that it's taking your mesh and processing it. So it might take, we'll give it maybe like 10 minutes to set up. And then there should be a point where it's actually gonna start showing something. Just call me over once, which is like. Yeah.
Professor, it's saying little before this is okay, right? It's still out.
It's over. Yeah, it's over. Trust me.
I keep checking it, 3400, right?
Yeah. Okay. Yeah, it's still.
I'm gonna trust in this tonight.
It's working. It's working.
Is there anything else?
Almost. Yeah,
I could start with this.
it says it's not responding, but it's working.
I wanna get new fasteners for sure.
Windows thinks it's not responding because of the way Windows.
It's
Because it also.
I could just do it because.
It's working, trust me.
Yeah. You need to pick up and slide in.
Okay.
That's my last.
So-
but it's up to you.
I finally got it.
Okay.
Then like going to 10 seconds. So it only shows up and doesn't give me an error for 0 and 1 second. Like it shows me right. And then 2, don't get errors. Alright, so-
So it's all red because of the color bar, because at time step 0, these are just the initial conditions.
Yeah.
So everything is 0, but at the first one. When rescale that. Okay, so this actually looks good. Same thing, so all the pressure goes positive, which is good. Most of your pressure drop is down here, which makes sense. There's a little strength, there's usually that, I shouldn't get like that, the pressure shouldn't go back up. So it looks like it's flowing through the stress, so the pressure goes down and it comes back up. So that part's being straight, but may only just because it's still kind of early. Was there any errors when you converted the
I don't believe so.
you have the converted results? Oh, yeah, these are all in. Can I see your this is the simulation. Yeah. This is the status. Okay. Yeah, it looks like it's convergent. So what I'm looking at here is I'm looking at this column.
Yeah.
So, this column here is basically like here. What do you just see that for each time step? You know, the whole thing falls together, and then usually by the third or fourth iteration, it should be reduced somewhere around 10 times. Which it is, so that's good. So I think your simulation. So just an issue with conversions. Let me try reconfirming.
See, type, see,
Oh, yeah.
this is the point plan.
And I
Instead of a vector, it's
thought
called.
66, but then you can multiply by 2.
When you change it. Yes, when it's.
Yeah, because that was way. I got the old man, you know, I got. Remember what he said like. If he said what I explained.
Yeah, you put a long way to select
Yeah, I don't
the cap, remember the.
There's also the total measurement.
See, my.
Oh, you know what? You know what?
No,
it's
so that's like.
Yeah, yeah.
Yeah.
That's the file. I don't get told.
So that's.
So you go So this might take a while.
I turned the simulation.
It might reach a point where it's sympathetic, it's not responding, but it's still working, trust me.
So once you get past, let's get this.
Okay,
Yeah.
okay. So what you should see that this should actually update. So you can see it's actually populating these things. Eventually, yeah. So you should, so it looks like the result file should be. 30. Yeah, we'll let that run. I'll come back to you. Anyways. Okay.
But then I rerouted the team version.
Okay.
But I
There's a
think
couple
it
things
needs
in there that you can
comments. I
change.
don't know if it's because I connected without.
Yeah.
So it's like this. I just like this. But then we put it through.
It was in the video. yesterday.
I think that if you post about it, it's
Yeah,
great. Standard. Make them not.
I mean, so.
No, it's a better process. Make them not.
Well, this might be there. How do
Or have it also. Well, you shift to storage. Can you go to the, so this is your.
I don't think it's the same, I'm Chris Ross.
Yeah.
I want somewhere we can just. Essentially. If I don't, I think I want to do the work up at the end of next week, I think a lot of stuff. It's one bit of just saying. So I can, I'll have some pieces of information.
And then, my goodness.
Try it out, get it, like, 90% of what you need to do that. And after that, it's just like spawn to them. Yeah. You know, like I want to figure out, I don't know.
John?
Are you talking?
Yeah, dude.
Oh.
Right, just do like.
You did like the princess.
How can I change back to a?
What's it doing from this?
I was having to. See how they put my.
So for these ones, they're separate,
See it? That's
they're
it.
separate,
Oh.
You just need
It's
to.
not embedded.
You can also do this. We use the same program.
so it looks like you just pointed to the shoulder, but not the actual. Not the actual.
I should need this one.
That's supposed.
So you can do opacity, so you can see all of them.
These ones don't matter because you're not.
The VT.
You can like kind of see that. You can kind of see it.
Yeah, we need to measure it. Want to see what possible. Try.
These things after. Yeah. What's that? What's all?
Yeah. So when you choose, that should scare.
It looks like it's great. Hardware store nearby. Pretty big new one.
Okay, it's. Oh, good. I think what you're gonna have to do, so Zimbabwe doesn't have statistics at all in the name. So then you may have to read this, with an underscore, or underscore.
This is nothing from what that is so fast.
Oh, so I didn't know.
Why not?
Yeah, I'm saying, you're not so fast. So go ahead and that is.
They don't sell hard.
I didn't read the data.
Yeah, so I think. I think it's not. Oh, good. But you have to resplit.
Good shipping time.
Oh, that's nice. If in the past, you had.
You know where we got last time was we
So I think you have to just, yeah, go ahead and split the resistance.
The values are wrong, but I just want to remind it just to make sure that it will work.
Sounds good. Okay. Oh, it is. Okay, so looking at the visual is this third. It's really slow, just because it's, hopefully that goes down. So what we're hoping for that third number. If it starts to go down, that's good. But you really, we did everything we could for this one, and you reduce the inflow. I mean, we could reduce the inflow down. You could try instead of 5 to 1. But we reduced the time step size to 1.1. Yeah, if it still doesn't work, could be a mesh quality study. Usually it's not just bad. It's afterwards, it's finicky, but once it creates a mesh, it's usually pretty stable. There are some niche cases where may cause it to, but usually that's not the case. Okay, okay. So we got to the next one. So it looks like we went up. Mine is just looking. And keep an eye on this, please. Hopefully it'll start. Go down below. But it's good. But at least it started. At least within the next maybe 10, 15 minutes. Yeah, if it's still not going down, we can try reducing the inflow again.
When you create a new signal, it overrides the previous. Right?
Yes, it does.
Like if you can change it.
Yeah. Yeah.
Right, just because, you know, the same, they were that,
Yeah.
there's like multiple different files with different pressures. The 68 sounded great to you for that.
Honestly, it sounds fun. It's pretty fun.
So I'll just.
Yeah. It depends on like adult rabbit, kid rabbit, 6 so yeah, 68 pretty reasonable.
Yeah.
Rabbit's actually similar to what I like the best. But 20, I think is a state too, for like when it's small.
Oh, yeah. I'm assuming that's it's like an orientation.
Yeah.
I said, I don't use 20.
Yeah, I think I'm. Okay, that's what we-
Poster.
Oh.
Let's go.
Yeah, because the pulse sound. So it's pulsatile and that one. So it did.
I just ran.
Yeah.
Oh, wow. Wow.
I just want to have waiting and looking at the softwares. I haven't done it. I know I threw myself down. I did that. It's really close. I remember last. It's kind of like when I had started. I knew there was some problem.
Yeah.
Those really.
It's then,
Yeah, really.
it's around another one, like,
I've done some. Yeah, yeah.
So you use a corporation and see how.
you get to pick it, there's so much.
The wall shear stress.
Alright, so.
One that these people want to make. But it's the wall shear stress pressure.
Trying to work on my posters.
Yeah, so right.
So this was my resistance.
So I did.
We can see over into our person. Make sure you know the bottom.
Pretty sure.
Yeah.
Oh, no, this is.
Actually, we should put that 360,000.
001.
Yeah. Oh, no, no, right.
Say 68. So your pressure was 68.
Yeah, 68, and then I multiplied that by 1.3,
Yes.
and then divided by
I
5.
just want to see the other, the rest of it.
It was, so 68 times 1,000.
The step construction.
68.
No, I mean, this is expansion, those two.
Okay, that's-
Divided by 20.
And these are just.
Sorry, so the 20 was only because of, because before the previous equation had divided by 1.
Uh-huh.
So then when you divide by 5, that already multiplied.
So
Yeah.
I had to change it.
Exactly, yeah. Keep it equal.
Okay, thank you.
Now, then we, freshman, you want to, with my math.
So the wall shear stress you can't actually see, because the wall shear stress is only small. Actually, the wall shear stress would happen.
Yeah. It was a 1,000.
So switch this. So wall shear stress is only on. So the street, there's no down, see what happened. It's like, but there's no wall shear stress. So the streamlines are actually on different costs. For wall shear stress, you know.
So this one change it really start.
Yeah. Yeah. Yeah, sometimes the wall shear stress can be like one small location. But that, those are usually kind of like, we call it edging, so. So most of the wall shear stress is kind of. It's pretty different. Yeah. So it's 1, 5, so. Okay, so before you two go, let me show you how to use it. Yeah, so you go to Canvas. So you guys are, so I know you guys are saying.
Yeah, but it's.
But you guys are gonna have to set the post go to file.
Oh,
Yeah. Okay, so for your guys' pulsatile, file, you're gonna go to Canvas, you can put a file. We're gonna download both and scale. So this is a map I'm sure that we use to modify this slope. This slope of that month is. We want to send that out to. You're going down. It's only like 20.
Well, there's one coming one.
It's like.
Yeah, but like.
It's like we're not gonna. Like if they're gonna have to have a fucking shift in a week. Ever lunches. Next week is the first.
I'm gonna do the 832.
So it's in the station. Actually, let me show you all. Why? Wow. So this is the file that's on.
These to be checking on, you can't have to do that.
On.
So.
There's a long.
So this is the whole stuff. So the way to read this all is.
I mean, I like, I think the whole bunch of hardware in there.
I could go search for it. They might have a patch.
Oh,
Yeah, but all these are scale, these numbers are scale, and that the average flow rate is not.
Mark, do you need anything else? I'm gonna try to send that.
For you guys, I don't think so. I mean, if you guys for arguing pages, you know, there's more. You charge your part.
We have-
I'll put a link on this.
The only thing I'm concerned about is, but I'm sitting on that. And don't probably have firearm.
You can do that.
Fire on license, right? If you need a license to own gun.
What I did, yeah, I don't know, you wrote it down.
Oh, you do? Oh.
What do you need a firearm?
Wait, this down.
To buy one hunter. There was a site I went to, and it said like I had to live in a fucking, like I had to have a firearm, like I'm like, that's.
Dylan doesn't have one, just got one, I guess me and Mark.
For you guys, were you
That's
And
it,
if you-
they're all his dads.
Yeah.
wanna make sure that.
That's the thing, is you don't actually.
Huh?
He does it legally his dad, but even if he's like, put his money, what do you get? That's like saying that you own a car, but it's under your parents' name.
So this is your new.
Are you need the, once I get,
Haven't tried.
you can try it again, I can, let me get home, cause I think I have it in my case.
Well,
But,
I didn't even know you had a cut computer.
I had like,
Scale goes up 2 months ago.
What did you get?
a block.
And so this is the same.
But, I mean, Marvin's gone, yeah, I can send it to you,
And so
once I get home.
go to.
I'm not super worried about it, but sure. That's something.
Let's see, once we got, let's call like.
Let's say this.
Well, we could go pick some up in person,
Oh,
but we, it's like, anywhere that, I know like Bass Pro Shop sells it, like
Oh,
anywhere that.
oh yeah,
sells-
there's one in Irvine.
Anywhere that sells guns, anywhere that sells guns, you can place.
Yeah, I didn't go to.
You have to have a firearm, like a current firearm.
Oh, yeah, I mean, do you wanna go next week?
Everything else. Although even for you guys, since you
Remember the big, did you see the big Bass?
Oh, the Bass Pro?
Off of the,
I know, Vince was like, should we stop? I wanna get a hat. I was like, let's just, you have some stuff. Yeah, I can do that too. I didn't go to the ammo section, the Irvine one, just. 'cause
Yeah.
They,
I never had to go to sort of off guard next week.
I feel like you're gonna Irvine, take on the one, like, sister and my dad.
Yeah, I
in
think
there.
that's.
And then you guys crazy.
Oh, it's funny, I'll be pretty easy.
The Costco one, like,
but it makes, bro,
that's
that's
the Costco.
it makes Costco.
It does.
Oh, really? It's awful.
Like one in Irvine, so I was like, I'm not gonna lie, it was like guaranteed at least like. Three stories. But it went down. It's like crazy.
I never been to back room.
That, I know the one off the. I'm sorry.
I don't know, I think it's probably gonna go.
Give it, we'll get a 10 more minutes. Let's see.
Thank you very much, Professor.
Yeah, no problem. Yeah, if you guys have problems. All right.
Yeah.
The board.
We already have black powder first, we have bead matches,
We have enough, why, we need, let me see your. The wells?
No, we have
One,
one.
your model
Two more.
particulars.
So we have the 8 we already had,
1, 2, 3.
but we already have, we have little bulkheads set. We have
Oh,
two additional.
oh, the
black
bulkheads are
powders.
Even with the second.
They're just not like like, they're bolt.
Like we have the wells.
Yeah, they have their little bulkheads fully assembled, they've been assembled for like.
The bulkheads, but with the wells.
I believe so.
I would say double check with them, just cause
I'll go down there.
cause last year's team for sure had.
When the files are created.
I was gonna say, cause last year's team for sure had 4, and then. We need 4.
Well, between last year and last, I'm not worried about that. Yeah, that's not gonna worry about. I'm just like, you know the way you started.
Oh, the little.
Like, dude, can I stay at Maggie? Yeah, I don't wanna like.
Buy well.
Like, actually, no, because if we're coming from the wood, like,
Oh, you're talking about for like the.
separation. We're gonna try to drag, but he's like wired up, like, in case that doesn't work, have your ship wired and ready to go to.
Cause then rather is popped.
Yeah.
Should be. I guess iron.
It'd be kind of looking at it, and then like I need to find some sort of.
I know what you're saying, you were saying usually all hexagon animation, you know, just because we stop, and then usually even then like, I don't know, it's mentioned stability. So everything like the delay, 2 seconds, the next is.
But it could be the rules are. Cause like, if you watch our video, you'll hear, he says, fired, and then it happens, so. You know, I mean, there's like a 1.5.
So we may have to take.
We have to take that.
So millimeters and centimeters are.
The map could go off, but it'll.
But
take
for
like a
flow
second
rate,
for it to
it'll
build
actually-
pressure and it actually.
Yeah, cause they
So
hit
we're
it, and
gonna,
then
we're gonna invert that to.
we hit it, and it takes a second.
Yeah, no problem.
And we're using a certain motor drain, so it's like. it'll, we're using the same motor casing and everything, so
The
it should
fact
be the
that
same
we
type.
are just with 0.1 mils. So it's like 5 mils. Or like.
I'm probably gonna go.
See what we can do, because now we have the email.
Yeah.
We divide it. This is how we like simulate like. The reason we wanted it for
I know.
10.
We could, we were done with the front one,
Instead.
with, with the lights.
Yeah.
It's dumb easy.
Yeah.
We didn't understand, remember I said if I was putting it short, it doesn't, it just creates a circuit. All you have to do is have.
Now that's go through.
Yeah, you
Yeah,
just.
because
need
that's
to
how the
have-
e-matches go through, they go across each other and like a little kind of like opening out. We could have just made our own match.
Well,
You need the tip of a match.
You need like, yeah, which I saw like a video where it's like, take an actual match, melt it down and
That's
then.
yeah, you cut it, you. Yeah, it pops it, not burning. You really need on the wire in such a small time. Oh, there's a high chance it's gonna fail. If you don't do the contact. Expect this not to make that drop.
Better to
Drop down. I think for us in ordering, this is a really slow. Like an R, just another board. Charlie,
Maybe run it, we need more. But I mean, like, we didn't even use any of ours last week, so just use this.
That's true.
Right now, you still have the 16 grams or whatever.
Let's try winning more than. That was enough for a single season. We'll do the steady one first, get that inverse, and then, yeah, and then once that works, that's. Is there a certain like, it's like, kind of like, not really, is there a certain like? Yeah, but that's, oh, there's no, yeah, yeah, I think it's probably a mismatch of units, so I think probably you just have to. Is there a certain way? Just, yeah, go and give that a try, send it to the cluster tonight, just email me tomorrow, see how it's. Yeah, thank you, yeah.
Did you just look at it real quick? So it finally, it got to 4
Okay,
and that's what it looked like. So, the like data for it.
it's still converting.
I didn't take a look at that yet, but. What did you click on to see that? The.
Yeah,
This one? It's in here.
So, okay, so, oh, did Vasquez say it was done?
Yeah, I did.
Oh, really?
So it stopped at 9 this time, but it went up, remember, it's like past 3 or past 2 of the noted.
I just typed in, I typed in black powder.
I think the one you use, cause I remember having this like, wow.
Oh, yeah, that is it.
Yeah, that's exactly.
I just looked it up.
No, I wish it was done.
Might be, maybe I'll try
But now
that.
that there's
Powder Valley.
it showed up, it just said like.
Well, just let you buy it.
Oh,
like, we did the previous
so I said, okay, and then, so this is at 4 seconds.
If,
and then
if not,
seven
like,
is
send that shit to the
Okay,
district too.
that looks.
And I don't even send this.
Yeah, it looks better.
Bro, it's just text.
How
It's
much
just, I think this should be a little red.
Okay, that's $30. It's like-
Okay,
it's
okay.
So I mean.
Because sometimes when you go
And
on.
then has $22 almost as much as it, and then adult
I'm not sure
signature
this one kind
required.
of
Coming back.
slanted a little bit, yeah.
But I think that's in
I'm gonna
general.
ask these guys.
That part's okay.
Ask them and then ask, I mean, I can.
Let's-
You can always look at that, it's better than buttons.
Cause
Okay,
people
I'll
do a
keep
lot of
going.
refills, and
Let's
you
see
do,
if I can
or
get it back. Maybe I
reloading,
just need to
do
press
reloading,
these.
so.
Yeah, I mean, you can also, I mean, you can try sending your results.
I mean, I'll post them this
under to me, just like converting it. I have a lot of RAM on my computer.
Okay,
Yeah, cause I know you're right, go check, that was the bottle you used, I'm pretty sure.
Yeah,
That would
super.
super. provide.
All salts in the city.
Yeah, you can try posing some of the applications and see.
okay.
But yeah, for the pulsatile one, maybe more challenging.
Have you, you have any training like tonight? Just check over.
I'll see if I can figure it out.
Okay,
yes.
I'm gonna.
Okay.
Activate an abstract.
Like, I'll be here tomorrow, later.
Okay.
Oh, that's not.
Okay,
Said 3 or 4.
Do 3.
Hey, Jim, people, sorry, I just noticed there was something in the chat. Let me see.
No, our time is up, so I'll do like 1.
So it might be like.
I mean, I'll
I
be
think
home by.
2 because.
Okay, good, Caleb.
I'll be home.
Hey, Peter, sorry, I missed your question. I think I still need to upload the template. So let me go ahead. I'll do that after when I get back to my office today. Yeah, thanks for catching that.
Right here.
Yeah, I just sent.
Here, alright, it's due at,
What is it?
oh no, it's 3 p.m. my time. PDT is our time, right? So PDCT,
PCT is our time.
PST, isn't it?
PST, Pacific Standard Time, yeah, PST.
What is PDT time?
Their time, I think it's a 2-hour ahead.
Oh, no, sorry, Pacific time. Okay, so it's due 3 p.m. our time.
Yeah, I'll try to get here at 11, 10:30.
I would hopefully, I'm gonna work on it tonight. I'm doing more of the technical for it. I haven't had like time to go straight to the. Too much, man. Finals and trying to get this converged properly.
Get it done. I just, they need to like, they need to give us another week.
All of their deliverables for competition have been straight up like in midterms and finals.
Yeah, that was the last one, yeah.